Similarly, distribution is also transferred into primary result. Primary distribution, secondary distribution. Mr. Rajesh, are you hear my voice?
Yes, sir.
Okay. Hello, sir. Are you able to hear my voice right now? Mr. Rajesh?
Yes, sir. Yes, sir. Your voice is very clear.
Thank you. And the power systems, that definition for power systems. Here I highlighted two red color words. So we have a question from these fields. What is the definition for the good power systems or weak power systems? So the power system is defined by two words. One is the short circuit capability, another is the harmonics. So good power systems are because strong power systems having high short circuit capability and low sensitivity harmonics. It's a vice versa for the weak power system. From these two definitions, we have one question. So what is the definition for? Which of the following is a weak power systems? Okay, and this question frequently asked in the exam. So weak power system having low short circuit capability and high sensitivity harmonics. So, as I told, so we have a transmission system and distribution system. So primary transmission, secondary transmission, primary distribution, secondary distributions. So in general, nearer to our home, we have a small substation there. In our home country, we have a circuit structure transformer is there. Here we have a distribution transformer which is close to the home. So we are able to see the transformer. So that transformer itself we call as a secondary distribution. So nearer to our house, we have one substation. That substation is called as the secondary distribution. So next, primary transmission, which is located nearer to the power station. So here, nearer to the power substation, that we call as a primary transmission. Nearer to our home, that is nearer to our Muntasa, that we call as a secondary distribution. So we have a question from these two terms. And so main thing, secondary distribution. That is secondary distribution usually utilized by the consumers. Okay. The consumers, most of the consumers are that is single phase consumers. So in Qatar, the single phase, the voltage for the single phase system is 240 voltage. 240 voltage plus or minus 6%. 240 plus or minus 6%. Especially in India, we have 230 voltage plus or minus 5%. That's why most of their home country is maybe different. That's why remember this verse. 240 voltage plus or minus 6%. This question also asked the exam. And in the power systems, just we start with the Ras Abupan and Muntasa. So there we have a power station, here we have a consumer. So we need to transmit the generated power from Ras Abupan to Muntasa. How we transmit the electrical energy? By using the wire. So here, so in general, here usually use the word wire, or in general, we call it a conductor. So we lay the conductor from the Ras Abupan to Muntasa. So say assume that we have a length conductor. So every conductor having its own length, cross-sectional area, and length of the material. So that's why if you are using a conductor means, yes, correct. So sending end, here we have a receiving end. In general, sending end we call as a locate just as a primary transmission system. Receiving end we have as a secondary distribution. Okay, and here we read the conductor. Okay, the conductor having finite length and having cross-sectional area, and it's made up of one length, made up of any metal, either copper, aluminum, whatever thing. So we have represented here rho. So that's why the conductor having resistance. So the transmission systems are distribution systems. In general, we have a resistance is present in the system. And assume that we have a odd phase, Y phase. B phase, we have a conductor. So two phases are there. And here it carries the power. We are transmitting AC power. So it carries the AC. So if it is a conductor, it is a conductor. In between these two conductors, we have air is present there. We are not able to put the air, but we are laying the conductor in the atmosphere. So that is between these two conductors, we have air is present there. The air is just like a dielectric media. So which means it acts as a capacitance. So in the transmission system, we have a capacitance. At the same time, it is a conductor. The conductor we laid in the tower. The tower is erected in the ground. So that is the capacitance between conductor and the ground. First I said that face to face we have a capacitance. Now I said that ground to conductor we have a capacitance. So in general we have a capacitance. And this conductor carries current. So it's a current carrying conductor. The current carrying conductor carries the current. What will happen? The flux is produced in the conductor. Just like that. So usually if it carries the current, so the current is flowing. Here we have an encircle things are there. The encircle rings we call as a flux. So that's why the conductor carries the current. The flux is produced. The correction of the flux we call the inductance. That's why in the whole the conductor we have a resistance, capacitance, inductance. So that's why we may say the transmission system having a RLC circuit. Okay, what are the parameters involved in the power system? Resistance, inductance, capacitance. And we say, we are saying the conductors. So more specifically, we may say copper or aluminum. So usually before Second World War, we are using a copper. After the Second World War, we go for the aluminum. And so when we say copper or aluminum, more specifically, the aluminum conductors further classified into 5 different types. So out of 5 types, we have a question from the 5th one. ACSR conductor, aluminum conductor, sealed reinforced. This is the conductor mainly used in the most of the applications. So even for the applications, our objective to get the license. So in our exam, this question asked in the exam. So we forget about the other 4 parts. So this abbreviations also asked in the exam. ACSR stands for aluminum conductor steel reinforced. So from this word, what we understand, the conductor having aluminum and steel. Okay. And the word aluminum conductor steel reinforced. From this, what we understand, in the center we have a steel, outer is a aluminum. Because the word itself we have understand. So just like this. So inner we have a steel wire, outer we have aluminum wires. That's why we say steel reinforced. Okay, that is the peculiar reason when you put a steel wire in the inner part that we discuss in the later stage. And the cost is on the steel reinforced conductor, 7 steel conductor, 24 aluminum strands. So this conductor is represented by this. So this ACSR conductor represented by number of aluminum conductors slash number of steel conductors. So for this particular diagram, the ACSR conductor represented by 24/7. So usually we have a question, this question. The ACSR conductor having 7 steel surrounded by 25 aluminum conductors, which is specified by. Okay. And how we spell this 25/7? So due to the curiosity, you go to the calculator, we divided 25/7. This is not the answer. So we spell like this, but actually we represent by 25/7. Because one of the engineers in the classroom, immediately we take the calculator, give the answer. So maybe unfortunately in your exam, that is option also that. So by mistake you may select the options. That's why I insist here. So number of aluminum conductor slash steel conductors. So in the transmission system, we have a conductor. And in the transmission system, we have either we have a EHV voltage or HV voltage. That is above 220 voltage or below 220 voltage. So right now that we have classification software, right now we classify the 2 categories. One is above 220, below 220. Above 220 we call as a EHV layer. So above 220, that is EHV line, we are using expanded ACSR conductors. Expanded ACSR conductors, and HV line we are using ACSR conductors. So ACSR conductor having aluminum and steel. So what is the definition for the expanded ACSR conductor? In between the aluminum and steel, in between we have filled by the paper. That is, this circle we call as aluminum and this circle we call as the steel. So in between these two, we have the filler paper. The paper is present in between these two. Then the conductor we call as the expanded ACSR conductor. So in exam point of view, where is ACSR conductor? where is expanded is a conductor. That we need to remember. That is EHP. That information we need to remember. And in the transmission systems, we have three important losses are there or effects are there. One we call it the skin effect, current effect, and coronal loss. So we have two wires, one is a black wire and the red color wire. Both wires having same length, same cross-sectional area, made of the same material, which means both wires having same resistance. Okay. Now we are giving the red color carries the DC current and black color carries the AC current. So black color wire carries a AC current, red color carries a DC current. The conductor carries the DC current. The current means electrons. The electrons are uniformly distributed in the conductor. If the AC current means the electrons are not uniformly distributed. So easy to understand. Just imagine that just like the DC current, just like a college bus. In the colleges, all the students are entered and sitting in the respected seats. Uniformly distributed. The same 60 students, if we take the government bus or private bus, then they didn't sit in the respective seats. All the persons are standing in the footboard. In the steps. That is, the electrons are not uniformly distributed. In the both the cases, the same 60% are there. So here the electrons uniformly distributed, here the electrons not uniformly distributed. The electrons are uniformly distributed means the area is effectively utilized. All the areas is utilized. It carries a DC. If it carries an AC, the entire bus, the footboard, the electrons only, the students are occupied. In the center part, there is no students are there. That is empty. So this again. So in the outer, all the students are standing. That means we call it the electrons. And the center is a empty. It is not effectively utilized. At the same time, if it is a DC, all the electrons are distributed uniformly. So from this, what we understand, all the area effectively utilized, Here is not entire area is not perfectly equalized. So R is equal to rho L by A. R is equal to rho L by A. This is the general formula for the both the conductors, because both the conductors we have same material, same length, same cross-sectional area. If now we are giving the DC current in AC current. Now what will happen? L remains same, rho remains same, but A physically both having the same area, but actually the current carry the area is reduced. If the carry the AC, if the area is reduced, what will happen? R is increased. So here area is reduced, that's why resistance is increased. So if the conductor AC, then the resistance value increases. So R AC. So say if the DC we take 100%, or we say 100%, then RAC we call as a 160% of RBC. Or we may say RAC is equal to 1.6 times of RBC. The two conductors we measure by measure, we have the same value. At the same time, to measure the resistance value by using voltmeter, ammeter method, if they give the AC supply, DC supply, we have different resistance. So RAC is equal to 1.6 RBC. So DC supply, what is the frequency for the DC supply? 0. So F is equal to 0 or is DC. F is equal to 50 Hz or AC is equal to 1.6 of RBC. Correct? So from this what we understand, the frequency increases, the resistance value is increasing. So as an electrical engineer, I am handling 50 Hz. So you electronics engineer, GCE, so you carry the same conductor is carrying the communication signal. In the communication signal in terms of 10 kilo, 10 mega. So that's why there also there is a significant gap. For electrical is 1.6 times, especially for a speaker. If you go for the communication signals, there the resistance value again is 2 increases. So in example from this what we understand, effective resistance RAC or the cause of R effective is directly proportional to frequency. If the frequency increases, R effective is increases. For understanding purpose, we don't know RAC, but in general we use the word R effective.
RAC is equal to 1.6 other DC only when the frequency is
50 Hz. And this is correct. And the 1.6 exclusively for 50 Hz. The frequency increases, the value increases. So I hope in your colleges you did an experiment for a circle diagram, especially for induction motor. In the circle diagram, you need to calculate the stator resistance value. To find the stator resistance value, usually you multiply into 1.6, especially in our home country. In India, we have 50 Hz. That's why we multiply into 1.6. Some of the countries maybe multiply into different numbers. So that's why this number, especially in our colleges, you use in the circle diagram. Okay. So this is the due to the skin effect, the center part we didn't utilize. And here sending into receiving. Last above we have a 100 kilometers. So we raise the conductor for 100 kilometers. So throughout the 100 kilometers, this area is not effectively utilized. Because this 100 kilometers into this cross-sectional area, it is not effectively utilized. Because the cost is directly proportional to weight of the conductor. The cost is directly proportional to weight of the conductor. So this red color is not utilized. That's why I remove this. So instead of the solid conductor, I use the hollow conductor. Because the what the skin effect, the electrons are surrounded, that we call it skin. So now instead of the solid conductor, we are using the hollow conductors. At the same time, use the hollow conductor, we didn't have the tensile strength. So that's why we are inserting the steel wire. So the purpose of using a steel wire, number one, to increase the tensile strength. Number two, to optimize the skin effect. Due to the skin effect, it can't utilize. At the same time, we insert the steel wire to increase the skin tensile strength. So skin effect. Number two, Ferranti effect. The Ferranti effect, just see the diagram, itself you have understanding. So sending end, we have 32 kV, but in the receiving end, we have 32.24 kV. From this, what we understand, receiving end is more than the sending end. So that because due to this Ferranti effect, the receiving end we have more voltage. So what the reason behind this? Because if the load is a capacity load or under low load condition or very light load, the sending end, the receiving end is high. That we discussed in the previous class. So if you have a capacitance always stores the energy in the form of voltage. That's why in the receiving end load, because the load means in the Microsoft there are so many customers are there, so many loads are there. In general, we have a lagging, that is inductive load. So if it's all the capacity load, what will happen? The voltage is little high compared to the sending end. So in exam point of view, we must remember currently affected means the receiving voltage is slightly greater than the sending end. Number one. Number two, what is the reason for the light load, capacity load? Under this condition, the value is little increases. And another thing, what is the voltage regulation? For the transformer, no load voltage minus full load voltage over full load voltage. For alternator, we call it a E naught minus V divided by D. And in the transmission system, sending end voltage minus receiving voltage divided by depends upon the person. And standing in the sending end means divided by sending end voltage. And standing in the receiving end means divided by the receiving end. So at any case, divided by sending or receiving end, the value must be becomes a negative value. So that's why due to the Ferranti effect, the voltage is always negative. Or in other words, we say capacity load, we have a negative voltage regulation. This question may ask in the transformer or alternator or power systems. All the three, the answer is same. Resistive, inductive, positive regulation, capacitive, negative regulation. Then we have a corona loss. The current loss especially occurred in the EHT line. Not other system, he didn't see that current loss. He didn't have the current. So only occurred in the EHT. If the conductor carries the EHT voltage, then the current loss will occur. So the conductor carries EHT voltage. Okay. The conductor is placed in the open area, atmospheric air. So the conductor is surrounded by air. Okay. Now the conductor carries EHT voltage. So before going to that, in the conductor, that is, this is the conductor, the surface, we have a air is present there. To understand this air, so here we have a air is there. Okay. And if the carries the EHT voltage, this air becomes ionized. The air surrounded by the conductor, it becomes ionized. Air is a dielectric media, but ionized air is a conductor. So that's why the area becomes like this. So black color is the layer of the conductor. The green color is the due to the EHT voltage corona loss, we have layer is present there. So a simple thing, corona loss, the air surrounded by the conductor becomes ionized. That due to the ionized, we have some losses occurred. That loss we call as the corona loss. Air is a dielectric media, ionized air is a conductor. Yes, only for the extra high voltage. The voltage is high. If we carry the EHT voltage, we may occur the corona loss. For HV voltage, we didn't see that. If we negligible amount, or we forget about that part. So especially EHT voltage, we didn't see inside the city. This is in the outer city. So in the late night, you may see these colors. That's a violet color. So if you have a violet color see in the transmission lines, especially you may see in the insulator set. So that violet color refers the corona loss present in that. At the same time, if you crossing this area, sometimes you may hear the hissing sound. So hissing sound, the violet color is referred, then it's a corona loss there. So this was also asked an exam. Then the same hissing sound will be referred in the induction motor also. When you go for a skew through the rotor, the skew through the rotor which is used to avoid the magnetic locking hissing sound. The screw cage induction motor, we refer the skew through rotor. And voltage regulation, current effect, we call it a negative voltage regulation. At the same time, we go to induction motor, we have a negative state. When we have a negative speed, the induction motor rotates above the synchronous speed. So the transmission lines is classified broadly classified based on the distance. So this was not asked in the exam, just I keep the slide. So transmission system is classified based on the three categories: short transmission line, medium transmission line, long transmission line. So just refer that distance 80 less than 80 kilometers, we call as a short transmission line. 80 to 120 kilometers, we call as a medium transmission line. Above 120, we call as a high transmission line. That's why we take the 120 as a reference point. Below 120, above 120, 130. So in your exam, they will use that exactly 120 or near to the number. By this way, you may select the target. So far, they didn't ask any questions related to this one. And one more information. Short transmission line, we didn't, what are the parameters involved in the transmission system? Resistance, inductance, capacitance. For short transmission lines, the capacitance effect, the capacitance is negligible amount. That's why the equal circuit for the short transmission line is just like a RL circuit. In our colleges, we solve this problem. We suppose the short transmission line refers to the RL circuit. So RL circuit is the example for the short transmission line. And medium transmission line. So the capacitance we need to consider. So that's why the equivalent circuit consists of RLC. So in your colleges, you may solve the problems. But in our exam, they didn't ask these problems. Just remember the circuits. This is we call the T model. This is we call the pi model. And long transmission lines, we are not able to segregate the resistance value, inductance value. That's what we call as the distributed system. In the short transmission, medium transmission, we may calculate the resistance, inductance for the entire length. For long transmission, we are able to distinguish the line. That's why we call it a distributed system for long system. Usually we do not like this. By this way, we represent the long transmission lines. Just for information only, just remember the 120, below 120, above 120. So transmission systems, in the output is a electrical energy. So in electrical energy, we calculate the two things. One is the efficiency, another one is the radiation. So how to find the efficiency? Efficiency output power by input power. Here, what is the output power? Power in the receiving end, because output power. What is the input power? Power is the sending end. So the efficiency which is equal to PR over CS. Okay, we have a losses. Losses means what the meaning? That is what? That is because I cannot. Because we have 100 kilometers from loss of one to Mutasa. So the losses refers the losses means I square R. How to minimize the loss? How to increase the efficiency? to minimize the losses. How to minimize the losses? Either reduce the resistance or I square R. So which is losses. Either we reduce the current or reduce the resistance. That way we can be able to minimize the losses. How to minimize the resistance value? For the formula for R is equal to rho L by A. So we decided we are using that all aluminum conductor, AC is a conductor. So that's why the rho is a constant. And the L cross conductor the 100 kilometers is 100 kilometers. We are able to reduce the length. So the length is one particular point, we can be able to freeze that L. And A, okay, how to reduce the resistance value? By increasing the cross sectional area. Okay, if the increases, the cost is increases. So we are able to increase the big wire. There is a big wire, the volume is increased. If the volume increases, the cost increases. That's why there is a break-even point to finalize the A. So that's why the R we are not able to, that much we are able to reduce. So to minimize the losses, the R is fixed one. One particular point is fixed. Then we go for the current. How to reduce the current? Yes, that's why in the primary transmission system, we are using the step-up transformer. The step-up transformer, the voltage is high, current is low. What is the difference of the transformer? Constant frequency, constant power. That is primary power, which is equal to secondary power. So primary power EP IP. Assume power factor is equal to 1. Say for example, say 100,000 voltage into 10 amps. See here secondary, we have a low voltage, high current. That's why here the primary we have a high voltage, low current. That's why usually we are using the step-up transformers. So higher voltage having low current. So we are generating in the primary stations, we are generating 33 kV and is step up by 220 kV. That way we can be able to reduce the current, which is use the losses, reduce the loss. Step up transformer, very bigger. Here 33 kV and it's step up by 220 kV. So voltage is high, so current is low. So current low, that current which is by the current is flowing to the transmission system. That's why current is low, we can be able to reduce the loss. That is the reason why you go for the step-up transformer. So that's efficiency. Mostly they ask the problem just for the information only. So if you know the efficiency, everyone knows that output power and input power. Here we need to apply that. So it is a transmission system or system. So output is here, receiving end. Input is here, sending end. That information only we need to define. This goes to the transformer, output or input, output is the secondary power. Input is the primary power. That information we know. Then we go for the voltage. Voltage regulation. VS minus VR divided by VR into 100. Sending voltage minus receiving voltage by receiving voltage into 100. How to increase the efficiency? How to increase the regulation? By decreasing this value. What is the difference? Difference which is equal to voltage drop in the transmission line. Here we have a VS. Here we have a VR. What is the difference between these two voltage? We drop here. So if we reduce the drop, what will happen? We are increasing the regulation. How to minimize the drop? The drop depends on drop which is equal to I into R. Actually, here we are discussing about the AC supply. So I into Z. I into Z which is equal to I into R plus JX. So to minimize the drop, we may reduce the resistance or reduce the resistance or reduce the inductance. So we are not able to reduce the current because our load, we need to maintain the load. So that's why the current we need to fix the value. We need to minimize the resistance and so I is equal to R plus JX. So by reducing the resistance value or reducing the reactance value, we can be able to get the better efficiency, the better regulations.
But excuse me, maybe we can ask him us on the exam, complex number. So
No, mostly we didn't have that type of questions, especially we have a problem, especially in the AC quantum numbers. Sometimes they do that R, yes, we need to find that impedance or power like this. For the power systems, they didn't ask that type of DC problems. We have a typical some problems or some questions are there, we will discuss right now. That question solved. The distribution systems having three different systems. So distribution, that is so see the diagram. In the diagram, we have a foam and we have small wire between the foam and the first tower. That wire we call as a service main. We have a house and we have a phase neutral. Yeah, we have three wires. Usually I think two wires and the GA wire. So we have these two wires we kept in the post. Okay. These wires we call as a service main. The service main, the house, and nearer to the pole. Near the house, we have small pole stack. That we call as a service main. Let me discuss again later stage and different terminology. So near our house, we have poles there RYBN. So we have four-wire systems are there. If you see the four-wire system, then this entire thing we call as the distributors. So it is a small wire. Okay, the small one base connected to the R base. Next house is connected to the B base like this. So this wire we call as the service main. And these systems we call as the distributors. So service main is the small wire connected between distributor to our energy meter. That we call the service line. And every house, so all the places. So here if you connecting a one wire, what the meaning? So you have wire and you put like this, that we call as a tapping. So service means we take a tapping from the distributors. The tapping means what the meaning? Just like a node point. So distributors, we have tapping set that. So see, just go to our home, native home, near to our house, we have a poles there, so many wires are there. So that means we have so many tappings. Every house has one load. So all the loads are connected from that. My house, they have 230 voltage. Your house, they have 230 voltage. All the loads having 230 voltage, which means all the houses are connected with the parallel connection. In the parallel connection, voltage and current is different. Depends upon every house, they have a different load, they have considered different current. So distributed means we have tapping is there. And we need to maintain the constant voltage that we need to keep in the mind. Distributor, which is having a tapping point and maintain constant voltage. Yes.
Some of the countries they have like main pole in their electrical system. They said like an warning below your
Underground.
yes. In the load is too much. What happened to the main networks like
The load is more.
yeah, when the all people consume too much power, more than the
Okay, now I understand that. So this the straight line we call as a pole. That we call as a pole. The straight line we call as a pole. Pole is one end is connected to the ground, and this we call as a cross arm. In the cross arm, we have a conductors are there, R phase, Y phase, like this. So this is the pole, and it is the cross arm. In this cross arm, we have a four-wire systems are there. And the same pole, we have another cross arm. In this cross arm, we have a three-wire system. So again, you go to the, imagine you go to the home country, near house, we have a pole, we have two lines on the cross arm sector. In the top cross arm, we have a three wires. In the bottom, we have four wires. And see these three wires, if you see, if you enter in the first street and go to the next street, all the three wires go to the next street transformer. So all these wires are feeders, this we call feeders. All the feeders are connected to the main wire transformers. So this wire we call as a feeder. This wire we call as a distributor. And this wire we call as a service line. And feeders, we didn't have any tapping point. So feeder, which is used to maintain the constant current. Distributor, which is used to maintain the constant voltage. And feeders, no tapping point. Distributor, having a tapping point. Okay, we need to remember these terms. Where we have a tapping, where we didn't have a tapping.